A Formula One legend takes instant acceleration to a whole new level.
As soon as you touch the throttle, the engine's gone.
Inside the Lotus factory, cutting-edge design.
Extruded aluminium technology was indeed pioneered by Lotus.
And racing-inspired acceleration.
This is all about racing, it is all about speed.
Come to life by human hands.
We give our people more ownership. That means people who work on the line, they check their quality.
The Evora. A champion-bred sports car generating speed with a trim physique. A car built for luxury, built for maneuverability, and built for speed. Speedmakers. Lotus Evora. A pioneer in Formula One racing since the late 50s, Lotus is a company focused on speed and precision performance. But after nearly a decade and a half of research and design, they've taken their sports car line even further, blending power with luxurious comfort to build a new flagship supercar, the Evora. With its cutting-edge featherweight construction, the Evora turns its modest 3.5-liter V6 engine into a muscle machine, launching it to a top speed of 162 miles per hour. And Lotus continues to push the Evora's boundaries. Its newest version, the Evora S, is a supercharged upgrade that boosts it to 345 horsepower. This added power launches the Evora S from 0 to 60 in a blistering 4.6 seconds, with a top speed of 172 miles per hour. But for Lotus, the Evora is more than just another fast sports car. It's a new offensive in the company's heated battle with their longtime rivals.
It was the first attempt of Lotus to build a car that wasn't actually designed to target their core audience group, which was mainly the niche and track-focused customer. So it was designed to attract people who drive a Porsche, Audi, but who still wanted a car that actually reacts as they were driving a track car.
To build a car able to compete with the likes of Porsche, Lotus stuck with its core philosophy of achieving speed, not with raw power, but with innovative, lightweight design.
The Lotus DNA has always been about lightweight architecture, has always been about fuel efficiency, so less power and less weight to achieve performance. And it was always the core DNA, and it will always remain.
The building blocks of Lotus's racing DNA were first established on the European race car circuit, where the company sped into the winner's circle by reimagining the design of their competition vehicles. Lotus developed the first Formula One car with a monocoque chassis. Called the Type 25, its design used the body to provide support along with the chassis, reducing overall weight. Another groundbreaking design came in the form of the Type 78. Using an ingeniously molded underbody and side air vents, Lotus designers created a vacuum underneath the car. Literally sucked to the ground, the downforce increased traction on all 4 tires. Each was a radical design in its time that would quickly become a Formula One standard.
All the programs we do, from GT to Le Mans to Indy to Formula One, it's all about trying to identify technologies that our future products can benefit from.
Now, Lotus is using its race car knowledge to build finely tuned automobiles here, at its factory in Norfolk, England. The plant is located on the spacious grounds of a former U.S. airfield, later occupied by the Royal Air Force. For Lotus, the old airfield is the staging ground for a new battle. But though the rules of engagement have changed, the mission remains the same: annihilate the opposition. But to crush the competition, Lotus doesn't rely on high-tech drones. Instead, the company employs a brigade of highly skilled craftsmen.
We give our people more ownership. That means the team leaders and the people who work on the line, they check their quality. It's everything about the people.
The lack of automation means the Evora is a completely handcrafted automobile. It also means the Evora has a longer build time than is typical at a factory.
The current assembly line with the products we're making, we're building 5 cars per day, and they are on 110-minute cycle time. So what we mean by cycle time is from when the car lands on the stage and the operator then begins his operations on it, which are a timed event, until the car has to leave the stage, we have 110 minutes.
To build a car worthy of the road and the track, Lotus has developed an 8-stage process completed almost entirely by hand. Chassis assembly, engine and transmission build, panel bonding, paint, body marriage, trim and final, testing, and finally, inspection. From start to finish, it takes over 70 hours to build one of these luxury sports cars. The first stage, chassis assembly, a 3-step operation that ends with an ultra-rigid racing-inspired ride. Step 1 of this operation takes place off-site at a dedicated construction facility in Worcester, England. Here, aluminum chassis parts are bonded into completed chassis sections. But before they arrive at this facility, chassis parts start out like this: large hunks of raw aluminum called billets. Heated close to 900 degrees Fahrenheit, the billets are forced through a die at up to 6,000 tons of pressure. The result? An ultra-light frame piece of superior strength and stiffness. It's a process called extrusion.
Extrusions is a technology a bit like forcing toothpaste from a toothpaste tube, only under much higher pressures. I have a piece of extrusion right here. You can see the complexity of the shapes that can be achieved by extrusion.
On the racetrack, extrusion technology has allowed Lotus to outmaneuver and outperform rival competitors with far bigger engines.
The principle of performance through lightweight, with a car like the Evora, we don't need 500 horsepower to make this a high-performance car because of its weight, and that is the Lotus philosophy.
Now, at the Worcester facility, the process of building the Evora chassis first begins by cutting the extruded aluminum rails down to size.
We then take them down and we cut them into then working lengths. So instead of being 20 feet long, we then reduce them maybe to a piece this long.
Next, the shortened rails are processed through computer-controlled milling machines, which punch precise holes through the aluminum. Now, it's ready to be made into an Evora S chassis.
And we'll then take a robot and apply adhesive to wherever we need to bond together, and then start to assemble the main chassis into an assembly fixture. So it starts to look like what you see over here.
From start to finish, it takes factory workers about 10 hours to assemble an Evora chassis.
Once that assembly has been put together, it is then taken as an entirety and placed into an oven where it's cured at 180 degrees centigrade for 2 hours. And this sets off the adhesive. It's a single part epoxy adhesive that needs 180 for a couple of hours to set it off, and then it's real strong.
After a cooling down period, the process is complete. Coming up, more air means more muscle. Pumping up the Evora's power with oxygen.
It goes from 280 horsepower right the way up to 350 horsepower.
And later, breaking the rules to beat the odds.
The approach my father had of innovation, not really having a lot of time for the rules.